So we have delta x equaling 1 kilometer, so a 1 kilometer train. And then Vx here is going to be 95 minus 75. So this is the train, and then this is the car. So this Vx would simply be equal to 20 kilometers per hour. That is the speed that is the speed of the car relative to the train. So we can say A is going to be equal to delta x equaling V sub x t. That means that t is simply going to be delta x divided by V sub x. And this is going to equal 1 kilometer divided by 20 kilometers per hour, and then 3,600 seconds per 1 hour. And we're getting that t equals 180 seconds, and then this is to pass train. Again, 20 kilometers is the speed of the car relative to the train. 95 kilometers is the speed of the train relative to the ground, and then 75 kilometers is the speed of the car relative to the ground. So that would be the 180 seconds to pass train. Now for part B, we have that essentially how far do you go in that 180 seconds? So we have Vxt. This is going to equal 95 kilometers per hour, 0.05 hours, and this is equal 4.8 kilometers. So this being the speed of the car, and then this being the speed of the train, right here, we're essentially trying to find how far the car traveled in that 0.05 hours while it was passing the train. So again, this is the speed of the train relative to the ground, speed of the car relative to the ground, speed of the car relative to the train. And this would equal and this would be relative to ground. And then part C is asking us, now the train and the car are driving in opposite directions. So T is going to equal delta x over, now here it would be Vx opposite. So here it'd be, again, 1 kilometer. Now instead of doing 95 minus 75, you do 95 plus 75. So this would be 170 kilometers per hour because, again, they're traveling in opposite directions, times 3,600 seconds divided by 1 hour, and this is going to equal 21.2 seconds. So this will be the time taken to pass the train if they're driving in opposite directions. And then we're going to, for part D, we're simply doing delta x equals Vxt, or simply just 95 and then times 1 over 170 hours, essentially. So delta x for part D would equal 0.56 kilometers. So that would be the car traveling relative to the ground if the train and the car were traveling in opposite directions. So this would be your answer for C. This would be your answer for B. And this would be your answer for A. And that's the end of the solution. Thank you for watching.